Okay, student. Now we'll see. Now whatever maybe the problem is given in the polar plot. Okay. So whatever the polar plot, a number of problems of the polar plot he is given. But now how to find that particular polar plot and to find the stability of the closed loop control system. Then I will take three cases such that I can explain. So whatever may be the problem in our examination maybe comes under any one of these three cases. Okay. So for that I just take one small example. Now let us take this example. G of s equal to k by, which we already solved, s into 1 plus st1 into 1 plus st2. Here the polar plot is crosses the negative real axis. There we already find the magnitude also, k t1 t2 by t1 plus t2, where the polar plot is crossing the negative real axis. I just take this example. Okay. So what is the polar plot? Now first of all you tell me what is the polar plot. Now type is 1, this is type 1, order is 3, this is order 3, omega equal to infinity, omega equal to 0, and this is the direction. And the polar plot is crossing the negative real axis, there the magnitude is A. The polar plot is crossing the negative real axis, there the magnitude is A. Here the magnitude is A. Now see here, this is the polar plot. What is A? A is the magnitude of the polar plot, where the polar plot crosses the negative real axis. That magnitude which we already calculated by using some procedure, and magnitude is A. Now this is the polar plot which is given to you, and the magnitude one circle is like this. This is the magnitude one circle. This is the magnitude one circle. Okay. And this is one polar plot which is given to you. This is the polar plot of open loop transfer function. This is the polar plot of open loop transfer function, where the polar plot crosses the negative real axis. That magnitude is important A. And now this is the minus 1 comma 0 point. You know that. Okay. This is the real part, negative real part. This is minus 1. No imaginary part. This is minus 1 comma 0 point. So what is the relation? Let us take first one relation for this. Now let us take this is the relation. Now this is case 1. I just take this as case 1. What is case 1? The case 1 is nothing but this is A, where the polar plot is crossing the negative real axis. The magnitude is A. This is minus 1 comma 0 point. Therefore this is A, which is less than minus 1 comma 0 point. And one more thing also I want to say before you start the polar plot, don't confuse this statement, you remember, such that you can easily. Okay. Now forget about these negative values and all these things, because these are the polar plot is nothing but magnitude and phase angle plot. Magnitude and phase angle plot is nothing but magnitude, modulus, all are positive values. Therefore, so this is the negative real axis, this is the lowest value. This is the lowest magnitude is here, and this is the highest magnitude. Don't see minus and plus and all these things. This is low, this is high, this is more high, this is more high, like this. Okay. This is the lowest value to the highest value. Okay. This is the lowest magnitude and this is the highest magnitude. In that way, this is also magnitude, this is also magnitude, because this is the low, this is high. That's what I am writing. A is less than minus 1 comma 0, and magnitude of A is less than 1. This is minus 1 comma 0 point magnitude. This is case 1. Now you tell me what happened. Now minus 1 comma 0 point is, now there are 3 points I want to explain here. Now while looking the problem I can understand that this is minus 1 comma 0 point. and this is the polar plot direction. Now your minus 1 comma 0 point is enclosed or not enclosed? Not enclosed. Minus 1 comma 0 point is not enclosed by the polar plot. Minus 1 comma 0 point is not enclosed by the polar plot. If minus 1 comma 0 point is not enclosed by the polar plot, don't do anything. The closed loop control system is simply stable. The minus 1 comma 0 point is not enclosed by the polar plot. It is left hand side, therefore not enclosed, system is stable, and I am already explained one problem previous to this. Okay, so anyway, we will check, it's not a problem. Okay, so this is the magnitude, and this is the magnitude one circle. Let us take, this is the phase angle. Okay, I don't know this phase angle, not a problem. Let us assume some phi. Okay, this is the reference angle minus 180 degrees, and this is the reference magnitude, which is 1. So now I want to touch here. Then what is the magnitude here? The magnitude is A. Phase angle is minus 180 degrees. When phase angle is minus 180 degrees, this particular frequency is called as phase crossover frequency. Now I want to touch here. Magnitude is 1. Magnitude is 1. Phase angle I don't know, phi. When phase angle is phi, this particular frequency is called as gain crossover frequency. Now see here. Magnitude G of j omega, phase angle G of j omega at some particular frequency. Now what is the magnitude? Magnitude is A. Phase angle is minus 180 degrees. When phase angle is minus 180 degrees, this particular frequency is called as phase crossover frequency. But what is the gain margin? Gain margin is nothing but reciprocal of magnitude of open loop transfer function at phase crossover frequency. At phase crossover frequency, what is the magnitude? At phase crossover frequency, magnitude is A. Therefore, 1 divided by A. Therefore, this is the magnitude which is equal to A power minus 1. What is the gain margin? The gain margin in terms of dB, which is equal to 20 log A power minus 1 base 10, which is equal to minus 20 log A base 10. Minus 20 log A base 10. Now see here, this is minus 20 log A base 10, where A is, what is A? Sorry, where A is less than 1. So let us take A equal to 0.1 because A is less than 1, for example. Okay. Now you take whatever may be the value which is less than 1. What happens? If A is less than 1, let us take A equal to 0.1. What is the answer? Now minus 20 log 0.1 base 10. 0.1 means 10 power minus 1. Therefore, definitely the gain margin is how much? Minus 1. 10 power minus 1 minus minus plus. So gain margin is positive. 100% gain margin is positive. So closed loop control system is stable. The second point what I want to say directly is definitely the gain margin is positive and phase margin should be positive without calculating because not enclosed. Okay, gain margin is positive, sir. Show me what is phase margin. Now see the phase margin. So what is the phase margin? Magnitude of open loop transfer function. Magnitude of open loop transfer function. Phase angle of an open loop transfer function at some particular frequency. What is the magnitude? 1. Phase angle, I don't know. At some particular frequency. When magnitude is 1, this particular frequency is called as gain crossover frequency. At gain crossover frequency, this is the phase angle. But what is the phase margin? The phase margin which is equal to 180 degrees plus angle of open loop transfer function at gain crossover frequency. At gain crossover frequency, what is the phase angle? Now phase margin which is equal to 180 degrees plus angle of open loop transfer function. What is the angle of open loop transfer function at gain crossover frequency? At gain crossover frequency, the phase angle is phi. but you know the value of this phi? I don't know, but I don't know the boundaries. This is minus 90 degrees. This is minus 90 degrees. This is minus 180 degrees. Therefore, this is greater than minus 90 degrees and less than minus 180 degrees. Greater than minus 90 degrees, less than minus 180 degrees. This phi, whose boundaries are exactly greater than minus 90 degrees and less than minus 180 degrees. This is minus 90 degrees, greater than minus 90 degrees, less than minus 180 degrees. So you take any value which is greater than minus 90 degrees and less than minus 180 degrees, definitely your phase margin should be positive, 100% positive. Am I right or not? Now, not only that, you can also observe as frequency is changing from 0 to infinity. Is it right or not? Practically the frequency is changing from 0 to infinity. The frequency is from 0 to infinity. In that, first frequency is gain crossover frequency, second frequency is phase crossover frequency, last frequency is infinite. What is the relation between GC and PC? Now the third point, what is the gain crossover frequency? The gain crossover frequency is less than the phase crossover frequency. Closed loop control system is stable. In the Bode plot also we can cross check. A gain crossover frequency less than phase crossover frequency. Bode is saying that the closed loop control system is saying stable. Polar is also saying that the closed loop control system is stable because gain is positive and because phase margin is also positive. Understand or not? This is very, very. So your problem may be of this kind. This kind means not the shape. Relation between A and minus 1 comma 0 point, where the intersection point of the polar plate crossing the negative real axis is less than minus 1 comma 0 point, not enclosed, stable, positive, and gain crossover frequency is less than phase crossover frequency. By looking the problem, you want to say all these 3 points without doing this lengthy calculations first. If the question itself is asking gain margin, phase margin, then you calculate like this. Okay, very, very important. Note down. Okay, and here also one important, this is the same problem. Now when A less than 1, when the system is stable, magnitude of A is less than 1. When magnitude of A is less than 1, closed loop control system is stable. What is A here? What is A? A is nothing but K into T1 T2 by T1 plus T2, which is less than 1, which means that when K is less than T1 plus T2 by T1 T2, generally it is always positive. So when K greater than 0 and K is less than T1 plus T2 by T1 T2, then the closed loop control system is stable. So this is the range is also you can find. This is the range of values of K such that the closed loop control system is stable, because generally the system gain K is always greater than 0. K is always positive. Therefore, this is by default condition. Okay, and K less than T1 plus T2 by T1 T2, closed loop control system is stable. Now this point is also important. Okay, now this is case 1. Your problem, don't see the shape. Your problem, see the relation between minus 1 comma 0 point and the magnitude of the polar plate, where the polar plate crosses the negative real axis. Understand or not? No sir, in my exam the problem is not like this, sir. So if your problem is not like this, so we'll see in any other case. Magnitude 1 circle means the point is given to you. Whenever he is given magnitude 1 circle, minus 1 comma 0 point is already given. Now this is the magnitude circle and this is the polar plot. When the polar plot crosses the negative real axis, there the magnitude is A, and this is minus 180 degrees line. Now see here. Now first we will see the condition. This is A. Where is minus 1 comma 0 point? Now this is minus 1 comma 0 point. Now see the relation. This is minus 1 comma 0 point. And this is the polar plot direction. See the direction? This is the polar plot direction. This is the polar plot direction. And this is minus 1 comma 0 point. Now your minus 1 comma 0 point is right hand side of the particular polar plot direction. Therefore enclosed or not enclosed? This is the direction and this is right side. Therefore minus 1 comma 0 point is, first you will see the relation between these two first. Now this is case 2. Now what is case 2? The case 2 is nothing but A, this is A, this is minus 1 comma, lowest to highest. A is greater than minus 1 comma 0. Magnitude of A is greater than 1. I don't want all these things. I want a small shortcut relation. Minus 1 comma 0 point is, now minus 1 comma 0 point is enclosed by the polar plot. Closed loop control system is unstable. Understand or not? Not enclosed. Stable, enclosed, unstable. Immediately I am saying gain margin is definitely negative, phase margin is definitely negative. Is correct or not? We will see, we will cross check. So I want to touch here. If I want to touch here, magnitude is A, phase angle is minus 180 degrees. Now this magnitude, now at phase crossover frequency, because phase angle is minus 180 degrees. Now see here, A at angle of minus 180 degrees. So at phase crossover frequency, what is the magnitude? At phase crossover frequency, the magnitude is A power minus 1. Gain margin is 20 log A power minus 1, minus 20 log A. But what is this example? Here example is A is greater than 1. So A should be greater than 1. Let us take A is greater than 1. Therefore A equal to 10 I am taking. So if you take A equal to 10, what happen? Because A is greater than 1, log 10 base 10 is 1 minus 20. Then what is the gain margin? Negative. How much you are expecting? Negative. Am I not? Now see the phase margin also. Okay, not an issue. Therefore, magnitude 1 circle, phase margin. If you want to find the phase margin, see magnitude 1 circle. If you want to find the gain margin, see phase crossover frequency, means angle condition. So here magnitude is 1, phase angle I don't know, sir. When magnitude is 1, this particular frequency is called as gain crossover frequency. So magnitude is 1, phase angle, gain crossover frequency, I don't know. At gain crossover frequency, what is the phase angle? Phi, I don't know. But I know the range. What is this? Minus 180 degrees. What is this? Minus 270 degrees. Greater than minus 180 degrees. Greater than minus 180 degrees. And less than minus 270 degrees. See, friend? Greater than minus 180 degrees and less than minus 270 degrees. So this phi range is greater than minus 180 degrees and less than minus 270 degrees, then you take any value in between these two. Therefore, definitely this phase margin is negative. When phase margin is negative, gain margin is negative, closed loop control system is unstable. And see the relation also. Omega is changing from 0 to infinity. 0 to infinity. First is PC, next is GC, last is infinity. What is the GC and PC relation? Now the gain crossover frequency is greater than phase crossover frequency. Now the gain crossover frequency is greater than phase crossover frequency. Closed loop control system is unstable. In the polar flat, in the Bode flat is also the same. Gain crossover frequency is less than phase crossover frequency, stable. Gain crossover frequency is greater than phase crossover frequency, unstable. Okay, and the relation here you can identify or not. Now when magnitude of A, when this equation, when all these relations are satisfied, when A is greater than 1. What is A? A is greater than 1. A means K into T1 T2 is greater than 1. Therefore, when K is greater than T1 plus T2 by T1 T2, closed loop control system is unstable. This is the relation where the unstable. Less than is stable, greater than is unstable. Understand or not? Now maybe your problem is like this. Maybe enclosed concept, maybe not enclosed concept. Okay, note down this. Clear or not? No, sir. In my exam, the problem is not like this. Maybe in some other case. Now see here, if the problem is like this. This is magnitude 1 circle. This is the polar plate. Now, this is the polar plate where the polar plate crosses the negative real axis. There the magnitude is A, and this is minus 180 degrees line. Now, what is here? What is the condition? Now, exactly if you observe, now this is case 3. What is case 3? Now, case 3 is nothing but this A. And where is minus 1 comma 0 point? This is the minus 1 comma 0 point, because this is magnitude 1 circle. This is minus 1 comma 0 point. Both are same. Now A, which is equal to, this is A, which is equal to minus 1 comma 0 point, and magnitude of A, which is equal to 1. A equal to minus 1 comma 0 point, and magnitude of A, which is exactly equal to 1. And you see the relation, minus 1 comma 0 point is, minus 1 comma 0 point is intersect, minus 1 comma 0 point is intersect with the polar plate, intersect with the polar plate, where the polar plate crosses, where the polar plate crosses negative real axis. This should be same. -1 comma 0 point is exactly intercept where the polar plot crosses the negative real axis. Now, if both are perfectly intersects, what happen? If not enclosed, stable, enclosed, unstable. If exactly intersect, now the closed loop control system is definitely marginally stable. Let us check this is correct or not. Then if I take a point here, see, what is the magnitude? Magnitude is A, or magnitude A equal to 1, same, 1 at angle of -180 degrees. But if you observe or not, when magnitude is 1, this particular frequency is called as, this particular frequency is called as gain cross of frequency. And when phase angle is -180 degrees, this particular frequency is called as phase cross of frequency. That is the gain cross of frequency, that is the phase cross of frequency, that is magnitude is equal to 1. Now that is the where magnitude is, phase is exactly -180 degrees. Therefore, if you observe here, now this is 1 at angle of -180 degrees. Phase is -180 degrees, phase cross of frequency. At phase cross of frequency, magnitude is 1 by 1, which is equal to 1. Gain margin 20 log 1. What is the 20 log 1? Exactly. No positive, no negative. Exactly. Now this is gain margin in terms of dB is exactly 0 dB. Now students, you may take A at angle of -180 degrees. But what is A? A is exactly equal to 1, no? A is exactly equal to 1. Both are same. That's why I write 1 directly. So gain margin is, if system is marginally stable, gain margin is exactly 0 dB. And what happened to the phase margin? You already know, but you can cross check. Now 1 at angle of, what is the angle? 1, that is the 1 at angle of -180 degrees. Magnitude is 1, gain cross of frequency. At gain cross of frequency, what is the phase angle? At gain cross of frequency, the phase angle is -180 degrees and +180 degrees. -180 degrees plus 180 degrees, which is exactly the phase margin is 0 degrees. +180, -180, +180 and -180 degrees and +180 degrees. Exactly the phase margin is 0 degrees. Phase margin is 0 degrees and gain margin is 0 dB. Now definitely the closed loop control system is marginally stable. Not only that, what about the relation between gain cross of frequency and phase cross of frequency? The gain cross of frequency exactly same as that of the phase cross of frequency. Therefore, closed loop control system is marginally stable. When the closed loop control system is, this is unstable case. When the closed loop control system is marginally stable, when A equal to 1, closed loop control system is marginally stable. When A, what is A, which is equal to 1? So when K equal to exactly T1 plus T2 by T1 T2 greater, which is exactly equal to, then the closed loop control system is marginally stable. These are the three conditions you can get. When K equal to stable, when K is less than, K equal to marginally stable, K less than T1 plus, when K less than T1 plus T2 by T1 T2, closed loop control system is stable. Now, when K is greater than T1 plus T2 by T1 T2, closed loop control system is unstable. And when K equal to T1 plus T2 by T1 T2, marginally stable. Okay. Now these are the relations. Okay. Now your problem may be case 1 or case 2 or case 3. Note down. Clear or not? Those who understand these three conditions, you can easily find any difficult polar plot, easily answer. Just it intersects or not enclosed or enclosed. Then you can catch these 3 points, then you can easily find the closed loop control system stability. Now I am giving here as A, whatever may be, okay, in the given problem. Sometimes the magnitude itself is given, or you have to be answer for that. Now see, 2 marks question in the GATE examination is this. See how the question is given. Now this is also a very interesting question. Now let us see what is the question first, and these are the options which is given. Now these are the 4 options which is given. Now the question here is, this is the polar plot of an open loop transfer function. See here, this is the polar plot of an open loop transfer function, which is very interesting. This is the polar plot of an open loop transfer function which is given. Now when the closed loop control system is stable such that find the range of values of k. This is the polar plot which is given, and he is asking to find the range of values of k such that its corresponding closed loop control system is stable. One condition is given. Now closed loop control system is to be stable such that which of the following condition is correct is the question which is given. So now all these are the values. Now this is the polar plot crossing the negative real axis A, polar plot crossing the negative real axis A, polar plot crossing the negative real axis A. Now I want a closed loop control system is to be stable. I am giving one condition, you are observed or not. If the closed loop control system is to be stable, -1, 0 point is enclosed or not enclosed? If the closed loop control system is to be stable, -1, 0 point is not enclosed by the polar plot. Am I right or not? Okay, come. Now this is the polar plot direction. This is the polar plot direction, polar plot direction, polar plot direction, polar plot direction, polar plot direction. See here, very, very important point here. Now, if I write -1 here, see what happened? If I write -1, 0 point is here, this is -1, 0 point. Okay, you may take here also, you may take here, not a problem. But why you are taking like this? Now see here, This is the polar flat direction, right? Now this is the polar flat direction. This is the polar flat direction. See, this is our head. This is the polar flat direction. Which is right side? Which is left side? See here. This is the polar flat direction. Okay. This is the polar flat direction. Now see here. Now this is the left hand side. This is right hand side, right? Now this is the right hand side region. But now where is your -1 point, -1 comma 0 point? This is the direction of the polar flat. Now this is right side and this is left side. Now your -1 comma 0 point is not enclosed with respect to -2k and -0.2k. Let us take this is A1, A2, A3. Let us take. Therefore, now I can take like this: -1 comma 0 point, -1 comma 0 point is not enclosed by the polar flat with respect to A1 and A2. Am I not? With respect to A1 and A2, if you see here, this is direction, this is right side, this is left side, not enclosed. Sir, why it is not enclosed? If it is not enclosed, then only the closed loop control system is stable. So, if you substitute -1 comma 0 point here, no, it is enclosed. See here, this is the direction. If you substitute -1 comma 0 point, right hand side, enclosed, unstable. So, not enclosed, only stable, right? So, what is the condition here now? See here, this A2 is greater than, A2 is greater than, I am already saying lowest, highest like this. A2 is greater than -1 comma 0 point and this is A1, this is minus, and A1 is less than -1 comma 0 point. But what is A2? A1 value is already given. What is A2? A2 is nothing but -2k, which is greater than -1 comma 0 point. And what is A1? A1 is nothing, -0.2k is less than -1 comma 0 point. Magnitude, I want a magnitude of 2k, which is greater than 1, and magnitude means minus will become plus, is 1. Therefore, now see here, 2k is greater than 1. So 2k is greater than 1. What is k? 2k is greater than 1. So k is greater than 1 by 2. And 0.2k is less than 1. 0.2k is less than 1. K is less than 1 by 0.2. And k is less than 10 by 2, which is 5. Then what is the relation? Finally, see here. This is k greater than 1.2, k greater than 1 by 2, k less than. So when the closed loop control system is stable, when k is less than 5 and greater than 1 by 2, closed loop control system is stable. Is there any option like this? K less than 5 and greater than 1 by 2. Yes, this is 100% correct option. Am I right? Not? No, sir. I want to check. There may be another condition. You can check like this also. So now see, with respect to A3, if I take -1 comma 0 point here, what happened? This is the polar flat direction. This is the polar flat direction. But this is -1 comma 0 point. Flat. This is path direction. This is the point. Right hand side, enclosed. System is unstable. I want not enclosed case, then only system is stable. Therefore, don't kept -1 comma 0 point here. Kept -1 comma 0 point here. Right. Now what is the condition? Now -1 comma 0 point. Now can I write like this? -1 comma 0 point is not enclosed by the polar flat. With respect to A3. Now, if the -1 comma 0 point here, then the closed loop control system is stable. I want a stable condition only because system is stable. He is asking the condition. Therefore, this is A3, lowest, highest. right? Lowest to highest. What is the relation between these two? So A3, this is A3, this is minus 1 comma, A3 is less than minus 1 comma 0 point. What is A3? A3 is already given. Minus 8k is less than minus 1 comma 0 point. Now 8 magnitude means minus will become plus. So 8k is less than 1. Therefore k is less than 1 by 8. Closed loop control system is stable. So is the correct condition or not? K is less than 1 by 8, closed loop control system is stable, and K is less than 5 and greater than 1 by. If we find this condition all are not matching, this is only matching, you can get. There is no need of check this condition also. Okay. So this is the way the questions are asking. Very simple logic. Not enclosed, stable. So if you want a not enclosed case, where should I put minus 1 comma 0 point? So if you take minus 1 comma 0 point here, what happens? The polar plate is enclosed, system is unstable. If I take minus 1 comma 0 point here, polar plate is enclosed, system is unstable. So if I put here, now with respect to these 2 points not enclosed, if I put here with respect to this point not enclosed, like that, very simple logic. Okay, note down. Very, very important question. While you are solving this problem, and already n number of times I am saying, you remember this point. If you miss this point, everything will be goes wrong. This should be the lowest value. And if you go in this value, in this way, is the highest value. This will be reached the highest value. Means, now this value is very less compare with this. This value less compare with this. This value less compare with this. And like this, if you go, this is 1, this is infinity. You can remember like this. For easy example, for example, this is 0, this is infinity. You can understand. So that's such that you can understand. So this is A1. Okay, this is. Therefore, this is A1 is what I am writing, less than. Now this is A2 is greater than. Now this is A3 is less than. If I point here, this is greater than this. If I point it, this is greater, like this. Okay.